Hey physics, Mr. Hausman here. We're going to take a look at a level 1 compound circuit. We're going to be analyzing what we call the RVI, the resistance, voltage, and current of each resistor in this circuit. Now, you might be saying, why the heck are we doing this? Well, when you have real-life circuits and you are trying to figure out if they're actually working as they were designed by an electrical engineer or a computer scientist, what you need to do is you need to predict how much voltage they should be getting. And then if you're in the field and you're actually testing the circuit and it's not getting the right voltage, maybe it tells you something about another piece in the circuit that's broken, or maybe that resistor itself or that motor or that light bulb is not working optimally. So it's used quite commonly, and it's a really good exercise to see if you understand series and parallel, because in a compound circuit, there's both. Okay, let's get started. So let's take a look at what we have here. My brain sees this as a pretty straightforward circuit. I've got a power supply of voltage of 60 volts, and I've got 1, 2, 3 resistors. Now, in the first video you may have watched called Principles of Compound Circuit Analysis, you notice that what we do is we put on kind of blinders, and we kind of say, well, this whole circuit is too complex to think about. There is no formula that allows you to calculate total resistance. But what you can do is you can do something that I call the inside-outside system. So don't look at the whole thing. That's the outside. Look at just the parallel part. And let's put in a little label for that. Right? These two guys are resistance in parallel. And what we're going to do is we're going to try to simplify that and find what would be the equivalent resistance of a 12 ohm resistor and a 36 ohm resistor in parallel. And what we're also going to do is we're going to redraw it. Eventually you may not need to do this step, but we're going to put in a 60 volt battery. We're going to leave R1, and that's 6 ohms, that's R1, and we're going to simplify it down and say, I'm going to try to find the one resistance, right? And this is R1. And then we're going to call this resistor R23. What's equivalent to that, to 2 and 3 added together? And then the circuit goes back to the battery. So 12 to the negative 1 plus 36 to the negative 1. And then flip over everything, and you're going to get 9 ohms. Okay, we could show that right up here. R2 to the negative 1 plus R3 to the negative 1. Take the whole thing to the negative 1. So 12, negative 1, 36. And if you're getting strong at your calculator skills, that should be 9 ohms for the equivalent resistance, REQ, for 2 combined with 3. So we still don't have the total resistance. This is really the total down here. And most of us remember from series and parallel, we always start at the bottom table as opposed to going right to the RVI table at the top. So what we now have is we have to simplify it one more time. And now we have 2 resistors in series, a 6 and a 9, and we're going to replace that with a single resistor. And the 6 and the 9, of course, add up to 15 ohms because that's series. And we'll show that here. R1 plus R2 comma 3 is equal to R total, right? The total resistance. So 6 plus 9 equals 15 ohms. And now we finally have a total resistance for our circuit, 15 ohms. And the voltage was 60 volts. And I strongly encourage you to put that, that's the V of your battery, and put that in this table down at the bottom, okay? Now, next step, because now we've kind of simplified it down, that is really just a compound circuit that is equivalent to a single 15 ohm resistor. So let's use our past strategies. Let's find our I total, or the I at the battery. And we use Ohm's law for that, V over R. And we have 60 volts over 15 ohms, and you, of course, get 4. So that's 4 amperes of current. The I for the circuit is 4 amperes. Now, sometimes in series, we would just say everyone gets 4 amperes, but the next step is critical. where is the 4 amps? And the answer is the 4 amps must be from the battery, right, close to the battery, and anywhere the pathway has yet to split. So let's follow the laser pointer, right? Oh, it would still be 4 amps here. It would still be 4 amps here. Remember, current does not drop when it goes through a resistor. But then we have a junction, and the current is going to split, and we don't know how much each pathway is going to get, okay? So, but we have established a key fact. We've just established that R1 gets all 4 amps. Not everyone, just R1. Okay, what can we do next? We can't generalize and say 2 and 3, resistor 2 and 3 get 4 amps, but we can finish a row. And I refer to that as kind of, do Sudoku. When you have enough data, you finish a row. And remember, to finish a row, you just use Ohm's law, V equals IR. And so 6 times 4 is 24 volts. Okay? I, 4 times 6 ohms, 24 volts. Okay, now let's do something with that. Let's like make it connect back to the circuit. You just said that there's a 24 volt drop across R1. But if we use our color coding, remember the skill from the past, right? We know that it should start off at 60 volts, and that we just dropped off 24 volts. So if we were to color code, I'm going to use orange. Right now we're at a lower voltage. What's 60 volts, right, minus 24 volts? Well, we have, just making sure I've got it right, 36 volts. And does that mean that the other 2 resistors get that voltage? Well, let's check by using color coding. Well, blue means 0 volts. So therefore, if we've lost 24, what we just discovered is that the other 2 resistors, both R2 and R3, look how they go from orange to blue, they must get the 36 volts. And they both get the same. And then let's Sudoku it. But that's just a meaning, like, let's finish a row. Let's finish our analysis. Now we can do I equals V over R. 36 over 12 is 3 amps. 36 over 36 is 1 amp. And look what just happened. Can you see that you can actually check your work? If the top path, R2, just got 3 amperes of current, and the bottom pathway got 1 ampere of current, doesn't it make sense, and doesn't it follow the junction law, that the 4 amps coming in right here, splits at this junction, becomes 3 amps, 1 amps, and then it comes back together and is, of course, 4 amps on the way out of the circuit. So that's a nice level 1 compound circuit analysis with a parallel resistors inside a series.